So question 3 continues on this enthalpy of combustion theme, but with some graph plotting coming again from your practical endorsement. We're given a number of values, and the values, first 3 are plotted, and they want you to plot butane. So butane sat here, it needs to be bang on the 58 line, and it needs to be between the 2800 and the 2900 line there. Don't be sloppy, make sure that is absolutely correctly on there. So we'll take that off for a moment and have a look at the other side. So we have to use the graph to estimate the energy released during complete combustion of that amount of pentane. So first of all, we need to work out what the enthalpy of combustion is for 1 mole of pentane. So I've got what minus 3550 kilojoules per mole written on there, and I got that by continuing this graph down, extrapolating it, checking out what my molar mass was for pentane, taking it down to here and reading a value off the graph. Now they will be looking for a value. If you've drawn that accurately, your value should go between one of those 2 values just there. So mine came smack in the middle. So that's the value for 1 mole. We need to know how many moles we've got. So as soon as we've got grams of something, we're straight away, even if we don't know what else to do in the question, we are going to work out how many moles that is, which is that. So the total energy release will be the number of moles times the energy per mole. So that will be your number of moles times that value, which for me equals this one. Now I've just rounded it to that. It didn't ask me to. You'd be okay with that value, but actually everything else around here suggests, the 1.80 suggests I might need to keep to 3 sig figs really to be accurate. They will accept any value that comes between those 2 as a final answer. Part C. We need to double check this one. We can see straight away that we've been given an equation. Yeah, this is the equation of combustion for cyclohexane. We've been given some enthalpy changes of formation. So we know we're going to have to do one of these energy cycle type things. Now, it's always confusing. Combustion and formation are both mentioned. Remember, you're looking at the table and it says formation here. So if you like, you can draw your little triangle out here. Formation means you're going from the elements and you're forming those from elements upwards. So that means root 1 is your reactants plus enthalpy of combustion, and it equals root 2, which is your products values. And you can rearrange that to be that the enthalpy of combustion is the products minus the reactants. You can skip to this bit if you want, because you know you're working with formation, and if you remember, formation is always products minus reactants. After that then, let's just keep everything in the order of what we've got just here. Let's say delta CH is going to equal your products, which is 6 carbon dioxides and 6 waters, which all amount to that amount. Take away your reactants. So your reactants are that and that. Yeah, remember this is an element, and it's also any elements have a 0 value. So we're just going to take away that. Keep your brackets all in place so that when you put this in your calculator, you're doing that minus bracket minus bracket. That comes to that value down there. And that's an exact value, no rounding, because that was just adding and subtracting of these numbers above.